Angle of elevation and angle of depression will be mentioned in our stories. So let's first talk about what those are, and then basically what we need to look at today is where does the information from the story go into a right triangle representation of the story. So it's really just getting the numbers from the story onto the triangle, nothing new as far as solving the triangle, same thing we've been doing a couple days. All right, so what's an angle of elevation and an angle of depression? What does elevate mean? To go up. So basically an angle of elevation is an angle going up. Now where does it go up from? It's formed by a horizontal line, which doesn't have to be on the ground. Okay? A horizontal line, and then looking or up to something that's above it. So an angle of elevation is an angle that goes from a horizontal upward. Angle formed by a horizontal line and a line of sight to a point above the line. So in that diagram, angle 1 is an angle of elevation. People in the plane, the tower, the airport tower, are looking up to the airplane. Does someone really have to be looking all the time? No, that's just kind of some terminology we have to use. The line of sight is above it. So then angle of depression is going to be from the horizontal going down. Right. Ready for the next screen? Picture is the same on the next screen. Second screen, angle of depression is an angle formed by a horizontal line and a line of sight to a point that's below the line. So from a horizontal going down is an angle of depression. Keep in mind, it's from a horizontal. I guarantee there's some time today you're going to goof up. It has to be from a horizontal going down. Now, thinking about the fact that we mentioned horizontals twice, wouldn't this dashed line end up parallel to this dashed line? We referred to both of those as having to be horizontal. So then this line of sight that we've got drawn in there can be thought of as a transversal. So angle 1 and angle 2 are alternate interior angles that would always be congruent. So in a story, if we're trying to find how far up the plane is flying, like if we're trying to find this height, but it's not talking about the angle of elevation that's in my pictures triangle. If it's talking about the angle of depression, I can use my alternate interior angle relationship and bring the information down into my right triangle. So there's just a simple relationship between them. So angle of depression, angle of elevation. So I think I first have some pictures for you to just make sure you got angle of elevation and depression. We talked about everything that was there. Okay, so angle 1. Is that an angle of elevation or depression? Depression, because it's going from the horizontal down. Okay, 2. Elevation. 3. Depression. 4. So see where, now when the person is standing here looking, horizontal, okay, if they look up, they're looking at an angle of elevation. If they look down, it's an angle of depression. All right, I know that one's kind of pixelated, but grab your marker board. Angle 3, 4, 5, 6. Looking at what the angle's formed with. Is each angle an angle of elevation or an angle of depression? Does it go from a horizontal downward, or does it go from a horizontal upward? If you want to do a little bit of abbreviating, that's fine. And these started with angle 3 being an angle of, that's the angle, the vertex is over here, so it's from the dash going down. So 3 was an angle of depression, 4 was elevation, 5 was depression, 6 was elevation. All right, so let's use that in interpreting a story. It says the Seattle Space Needle, which is that building there, it has a point up on the top you can't see very well, but it casts a 67-meter shadow. If the angle of elevation from the tip of the shadow to the top of the Space Needle is 70 degrees, how tall is the Space Needle? Now in these stories, there's going to be a right triangle that would be involved. So the Space Needle, draw yourself kind of a diagram. Space Needle, we're going to figure out, I'm going to write out here so you can see it. We're going to try and figure out how tall that Space Needle is. Where would the shadow of the Space Needle be? Is it the slant? No. The shadow would be like horizontal on the ground. So we're measuring heights perpendicular all the time. So we're forming a right angle with the shadow and the height that we want. It says it's a 67-meter shadow. 67 meters. If the angle of elevation from the tip of the shadow to the top of the Space Needle, so they're talking about here, from the tip of the shadow up to the top of the Space Needle, angle of elevation, is that the one at the bottom or the top? Elevation would be the bottom in this picture. So that's 70 degrees. How tall or how high is the Space Needle? Solve the triangle. Or not really solve the whole triangle, but find the missing height using your trig. Figure out how tall the Space Needle is. You're just finding the missing side of your triangle. Which trig ratio, since it's not a 30, 60, 90, trig ratio, use to solve it. We wrote 60, but it should be 70. So from the 7. Adjacent and opposite. What angle? Okay, that's what fraction. What is opposite? One. This. Tangent. For tangent, opposite has to go on top, adjacent on the bottom. Yeah, there's some. If you need a calculator, there's some, but should be bringing your own. I'll make this up, borrow. And it says round to the nearest meter. That's what I've seen. Oh, yeah, don't do meters. Use inverse if you can. Okay, looks like 184, is that what it's on? 184. Oops, one too far. Okay, so what you should look at is your setup correct? I was asked, does it matter if the y is on the top or the bottom? Yes, it does. It makes a big difference. How do you know which place it goes? Well, if you're using tangent, tangent is opposite over adjacent. So what goes on top has to be the opposite length from the 70-degree angle. How we got that right? Okay, next story. Okay, this one, suppose a plane is at an altitude of 3,500 feet and the angle of elevation from the airport to the plane is 29 degrees. So you've got an airport and you've got a plane. Keep in mind there's a right triangle that we're trying to get put together here. You've got the airport and the plane. It says the horizontal distance between the plane and the airport is what you're trying to find. We know the altitude of the plane, 3,500 feet. Altitude, perpendicular, height. The angle of elevation from the airport to the plane is 29 degrees. Angle of elevation, horizontal going up. Okay, think you got it drawn? And solve it. Find what that horizontal distance is. If you would draw your triangles kind of close, a 29 degree shouldn't look like a 70 degree. It'll help you see if your answer is logically makes sense in the picture. Or should it be that much bigger or just a little bit bigger? Draw it a little bit to scale. All right, you've got it pretty good, except this is not the angle of elevation. Angle of elevation goes from a horizontal up. From a horizontal up. So like your airplane, your airport would be down here, plane is up here that you're looking at. It's still going to be tangent, but this one will be on top because that's opposite. This one, just multiply. Okay, you put your altitude in the wrong place. Altitude is perpendicular height. So 3,500 should do this. That's what this tangent is. You got it written down right. Put the standard on something like that is 4 decimal places. If we can do it without really having to carry this decimal, like if we just know that we're gonna have to divide by tangent 29, instead of pulling the decimal out right now, we could just put E equals that divided by tangent 29. Like that. All right, the right answer? Let's see. See if your check, see if your setup was the same. 6,314 feet. Now, if you made a mistake, check to see, did you use the wrong trig ratio? Did you have the wrong opposite and adjacent? Was your fraction upside down, that kind of thing? Did you cross multiply correctly? And I didn't give a lot of detail on the cross multiplying there, but I can show that. You need me to fill in some details? How many got it right? Okay, we did last time. Okay, so specific questions to ask? Okay, if not, here's another story. Now we have an ice climber standing on the edge of a crevasse, however you want to pronounce it. What is that? Yeah, that's the big opening. So I'm like at the edge of a big drop off. Okay, so this person's at the edge of the crevice, and that crevice is 115 feet wide. The angle of depression from the edge where she's standing to the bottom of the opposite side is 52 degrees. So she is the ice climber. How deep is the crevice at this point? Now read carefully again. Angle of depression. I'm going to bet that over half of you put that wrong in the picture.
Is that right?
Angle of depression formed between a horizontal going down. That picture works with an angle of depression, yes. But that kind of picture does not. And this is what a lot of you are showing me, this kind of thing. See where the 52 is? You've all made the same mistake. So where's that angle of depression? It's not the angle, yeah, it's not, well, do I have to completely turn her triangle? No, yours will work. I'm gonna just say, okay, if I would go horizontal, this is the 52 degrees. That angle out there is the 52 degrees. So if you want this angle, you have to do its complement. The angle of depression for a horizontal going down, 52 degrees. But you could bring that alternate interior into your picture, 52 degrees down there. Make sense what I'm saying? So everybody practically did the same thing. You have to have a horizontal. A couple of you are drawing the triangles differently, and that's working. So just to clarify again on that angle of depression, if you are doing the angle of depression from the horizontal down 52 degrees, you either have this as your triangle, which is what some were showing, or if you have this other one, this orange one as your triangle, then your angle of depression should come down as your angle of elevation in the orange triangle. So depending which triangle you're using. That makes sense? Because this angle would be 38 degrees if you wanted it. So do you have the black triangle or the orange triangle? Be careful what your angle at the top of the orange triangle is if you did it that way. All right, answers? I'm seeing 147 for most of these. 147. Upside down. All right, clarifying. Okay, are you writing like the tangent of 52 equals putting that over one? Okay, so you're doing this. So you got that? Okay, you're multiplying this. Okay, in this case it's multiplying. Let me see your calculator. How would you enter that? Hang on just a second here. You're not finishing that parenthesis. You can leave that open, it's gonna multiply 52 and 1
I guess in some ways I act like
Okay. Next story. Here you go. What's next? A fire. Okay, now think about drawing the picture and putting the angles in the right places. We have a ranger that's in a 90-foot tower, sees a fire, and it's out in the distance a ways. Now be careful, the angle of depression to the fire is 3 degrees. Angle of depression. So think where that ranger is when they're seeing the fire. They're in the top of the tower. So top of the tower, looking down, depending where you draw your triangle, that could be in your triangle, it might not be in your triangle. What's the horizontal distance to the fire? That's not the, well, the picture's okay, but your angle of depression is not in the right spot. Angle of depression. Yeah, that works. Is that? Yeah, that works. Your angle is not, that's not an angle of depression because it's from the vertical. It's not from the horizontal. Okay, now where's your 3 degrees? My angle of depression would be here from the horizontal down. So the way I drew my triangle, the 3 degrees was not in my triangle. So what I did was, or what I will do is think, okay, that angle of depression is the same as the angle of elevation. If somebody were at the fire looking up to the ranger, that angle would be the same as the ranger looking down at the fire. Alternate interior angle idea. Some of you switched and made the upper triangle. That works. Ava, can you see? Could you leave it as this bottom one? Yes. Yep. So now you're trying to find what the horizontal distance is. Which one? You're trying to find the horizontal, not the hypotenuse. Looks like the answer's coming out 1,717. You're at that time button. Have backwards again. So you had like the wrong thing on the top. You have your 3 degrees of Okay, let's talk about this angle a little bit more because there is something else you could do. Okay, up here. What's the relationship between these 2 angles? This skinny one and this big one? Complements, because if this is perpendicular, this would have to be perpendicular to make a horizontal again. So if my angle of depression is 3 degrees, what's the angle at the top of my right triangle? 87 degrees. Not the green that I've highlighted really, but just that part of it, 87. So if you would like to use the 87 degree angle instead of the 3 that's down here, you can sure work it that way. But you just cannot use a 3 at the top of this triangle. That wouldn't work. Okay, what comes next after fires? Okay, this one we're measuring the height of a tree. We probably need to do this one and one more quick one. Measure the height of a tree. Mrs. Frank's putting a protractor on a 3-foot table, and then I'm gonna get down and measure the angle of elevation, go up to the tree. So what's different about finding this one? Can you draw me a little picture? So we've got a tree. And instead of me laying on the ground, I'm putting my protractor on a table. And then I'm measuring the angle of elevation to the top of the tree. Where's the angle of elevation? I'm going to go from the protractor, horizontal, up to the top of the tree. It's not drawn to scale, but there's my 60-degree angle. 60 degrees it says. The protractor is 34 feet from the tree. So where's 34? 34 is the bottom here, yep, 34 feet. So going up, I heard Megan say, hey, it's a 30, 60, 90 triangle. Yes, it is. So you don't have to use the trig ratios. Which side did I give you of the 30, 60, 90? Is that the, let's see, is that the short leg, long leg, or hypotenuse? It's not drawn to scale very good, so it's hard to tell from my picture, but it's going to be across from the 30-degree angle. So that's the short leg. So if I'm using the 30, 60, 90, I would multiply that times the square root of 3. To get across from the 60. I wish I could redraw my picture. If you don't like what I'm talking about, do the trig ratios. Come up with what that is. What is 34 times the square root of 3? There are options to this problem. 34 times the square root of 3. 58.89, I'll say for right now. And if you did the trig ratios, it should come out to be that same number. Okay, now that's not the answer to the problem. The problem's asking how tall the tree is. The tree is not 58.89 feet tall. Okay, because of the table where the protractor is, okay, it's 3 feet up from the ground. So don't I have to add on 3 feet? So add on 3 more feet. So the tree is more like 61.89 to the nearest foot. That would be 62 feet. So on that one, the idea of you're not at the ground level, you're up a ways. Okay? So add that on or think about that to finish that problem. And then the last thing we need to look at is 2 triangles being used in one problem. Okay. So, all right, so we're going to make kind of a fancy picture. We have an observer in a lighthouse. Keep in mind there's going to be 2 triangles going on here. Observer in a lighthouse is 69 feet above the water. It's all right on the board. Okay, so we don't have too many lighthouses around Nebraska. But lighthouse is looking out over the water. So here's our lighthouse. Looking out over the water. It's 69 feet tall. He sights 2 boats in the water directly in front of him. Angle of depression, be careful, to the nearest boat. So if I go horizontal and look down at a 48-degree angle, angle of depression is 48 degrees. Here I'm seeing the closest boat. We're going to need to know how far that boat is away. So why don't we do that before we go to the next part of the story. Okay, we got a 69-foot height, 48 angle of depression. We want to know how far that boat is out on the water. Sine, cosine, or tan. Shall we bring the 48 into the triangle? You want to go alternate interior with it? So bring it down here, 48 degrees, instead of up there. Opposite. Looking for adjacent. Trig ratio is tangent. Tangent of 48 over 1 equals 69 over x. Cross. Multiply. Divide by the tangent of 48. And I know it says nearest foot, but that's at the end, so let's keep hundreds. 62.13. If you want to keep all the decimal, and you can, go ahead. Okay, so we know how far that first boat is. Now let's read about the second boat. The angle of depression to the other boat is 22 degrees. So the same person looking out at a smaller angle means that boat's going to be out further. So second boat, 22 degree angle of depression. We'll bring that down into the orange triangle, 22 degrees. Now let's see what the distance is for that second boat. Because we're going to try and find how far the boats are apart when we're done. So focus on the orange triangle, still 69 for that height over there. So it's still opposite and adjacent. Tangent of 22 degrees over 1 equals 69 over y. Okay, so y times tangent of 22 equals 69. 69 divided by the tangent of 22 degrees? 170.78 would be to hundredths again. All right, so that's how far out the second boat is. The question asks, what's the distance between the two boats? Well, you can find that simply by subtracting how far the second boat is, 170.78. Subtract the distance that the first boat is out. That was 62.13. And that will give you the distance between the two boats, which is how much? 108.65. So to the nearest foot, our answer should be 109. So it comes out 109, I think we said. All right, so the idea of the two triangles, I think on your homework, there's one where they've got the space shuttle going up. It's two triangles going upward instead of out. And I think there might be another one about like the distance across something. I don't know what the story is about. But those are the types of things we finish up the chapter. Sound kind of fun? Yay! 47 up here will be the assignment.